Here we will see event source database pattern in microservice architecture. Event sourcing is an architectural pattern in which the application stores every change to the state of an entity as an immutable sequence of chronological events rather than storing only its current state. The current state of an object can be reconstructed by replaying all the events that have occurred. Events are stored sequentially in a log or journal that allows the program state to be restored by replaying those events. It is commonly used in domains like finance and e-commerce, where accurate historical data tracking is essential. Event sourcing in system design revolves around several core concepts and components. First is event. These are permanent records of the system state changes that contain all the information that required to rebuild the system state at a specific point in time. Then event source. It is a durable storage that maintains the complete stream of events in order and acts as the source of truth for the system. Messaging systems like Apache Kafka or RabbitMQ may also distribute these events. Then aggregate. It is a logical group of related domain objects that processes commands, applies business logics and generates events. Each aggregate is associated with its own event stream. Then command. Commands are requests that are issued by the clients or system components to perform actions which are validated and processed by aggregates. Then projection. It is a read model created from event streams to represent the current system state for efficient querying and reporting. And event bus. It is a messaging infrastructure that enables asynchronous communication that allows components to publish and subscribe to events. The steps to understand how event sourcing pattern works are: first is capture events instead of state. Here every system change is stored as an event, such as order created or item added, instead of only saving the final state. Then store events in sequence. Here events are stored in the exact order they occur. That forms a chronological event stream which acts as a system source of truth. Then reconstruct state by replaying events. The current system state is rebuilt by replaying and processing all stored events from beginning. Handling new events. Here new changes generate additional events that are appended to the sequence without modifying previous events. And replay events for debugging. Events can be replayed to trace system behavior, understand state changes over time and investigate issues or errors. For example, suppose a customer places an order. Then at step first, command is executed. Here create order command is executed that asks the system to perform an operation. Then it is passed to business logic, where the order service validates the command. Then order created event is generated and this event is permanently stored in the event source. And these events like inventory service, notification service can be processed to update a database. There are different situations where you can use event source database. First, strict auditing and compliance. It is used with the systems like financial, legal or medical systems that require an unalterable log that shows who is changed the system, what is changed and when it is changed. Then time travel and replay. When you need to reconstruct an entity's exact state at any past moment or undo bugs by replaying event logs. Then complex business domains. When business logic depends heavily on the history and sequence of actions rather than just the final snapshot. For example, banking transactions, inventory tracking or booking system. And event-driven microservices. When multiple independent services need to react in real time to state transitions via an event-driven architecture. And there are some situations when you don't use the event sourcing. For simple CRUD apps, when your app just creates, reads, updates and deletes basic records with no need for history, then don't use the event sourcing pattern. Then static or lookup data. When you are working with reference data, basic configurations or catalogs that change infrequently. And tight deadlines or limited skill. When your team lacks experience with eventual consistency and complex asynchronous debugging, don't use the event sourcing pattern. Key advantages are complete audit trail. Here every state change is preserved. Then historical information. You can determine what happened at any point in time. Then event replay. Here events can be replayed to reconstruct state. Works well with event-driven architecture. Here events can be consumed by multiple services. And debugging. Developers can inspect the sequence of events that produce a particular state. And new read models. A new read model can potentially be created by replaying historical events. And disadvantages are complexity. Here event sourcing is considerably more complex than traditional CRUD operations. Then storage requirements. All events are retained, so storage requirements can grow. Then event versioning. Business requirement change, so older event formats may need to remain compatible. Eventual consistency. When read models are updated asynchronously, there can be a delay. And difficult event corrections. You generally don't edit an old event. Instead, you create new corrective event.